lecture, we have to see the next point of elementary reaction. Then what is meant by elementary reaction? Elementary reaction is the reaction which takes place or which occurs in a single step and cannot be broken down into another steps or as elementary reaction. That means elementary reaction can occur in only a single step reaction. For example, if you take the general example, A gives product B. A gives product B can be broken down into the three steps. First, A gives B. In second, B gives C, and in third, C gives D. If A reactant is directly give the product D, then it is called as elementary reaction. A gives the directly product D, cannot be broken down into other simpler steps, and these three steps followed by the reaction, so this is called as complex reaction. That means in the reaction there are two types, elementary reaction and complex reaction. Elementary reaction which occurs in a single step and cannot be broken down into other simple step, and in complex reaction which is formed in a one other than one step. If we take one example, that is ethyl iodide. Ethyl iodide gas gives ethylene molecule C2H4 gas plus hydrogen iodide gas. This reaction follows only single path. That means it is only a single step reaction. So this is called as elementary reaction. Yes, understood? Next point we have to see is the molecularity of reaction. There is involvement of number of reactant molecules. In this reaction or molecularity of reaction, it is the elementary reaction in which there is involvement of number of reactant molecules. That means number of reactant molecules taking part in the chemical reaction is called as molecularity of reaction. There are two types which is based on the molecularity of reaction. First one is unimolecular reaction and second one is bimolecular reaction. In unimolecular reaction, there is involvement of only one reactant molecule. If there is only one reactant molecule which takes part in a reaction is called as unimolecular reaction. For example, we take ethyl iodide gas gives ethene molecule plus hydrogen iodide gas. There is only one reactant molecule which is a ethylene iodide C2H4 and gas is take part in the reaction and having the only one reactant molecule. So it shows the unimolecular reactions. Second part is bimolecular reactions. The bimolecular reactions are the elementary reaction in which there is involvement of two reactant molecules or two reactant molecules take part in the chemical reaction is called as bimolecular reaction. Example for bimolecular reaction is ozone gas plus nascent oxygen gives twice O2 or oxygen gas. O3 gas plus nascent oxygen gives twice oxygen gas. In this there are two reactant molecules, ozone gas and nascent oxygen, which shows a bimolecular reactions. Again, if we take another example, NO2 gas gives NO gas plus O2 gas. In this second example, there are two reactant molecules of nitrogen dioxide gas NO2 gas, which shows a bimolecular reactions. Next point we have to see is the rate determining state. Then what is meant by rate determining state? Also called as RDS. That means rate determining state. In the chemical reaction, there are various series of reactions. There are series of reactions taking part in the chemical reactions. The slowest step in this series is called as a rate determining state. Consideration, we take one example, NO2 Cl gas, which gives twice NO2 gas plus Cl2 gas. This reaction follows the two steps, which follows two steps. In first step, NO2 Cl gas gives NO2 gas plus chlorine gas. This is a slow step. In second one, NO2Cl, the next molecule of NO2Cl combines with chlorine gas, gives nitrogen dioxide gas plus Cl2 or a chlorine gas. This step is the first step. Therefore, overall reaction is NO2, two molecules. In this reaction, we take two molecules of NO2Cl gas, which gives nitrogen dioxide gas of 2 moles plus Cl2 chlorine gas. See here, in this reaction, the first step of simple reaction is a slow step, and second step is a fast step. Which is the rate determining step? The first step, which is the slow, is the rate determining step, because it is slow, which shows the rate of that reaction. Is called as a rate determining step. Next point from this example we have to see is the reaction intermediate. Reaction intermediate. Then what is in reaction intermediate? Reaction intermediate, which form in first step and consume in a second step, is called as a reaction intermediate. See here, in this example, the chlorine gas is formed in the first step, and in the second step it is consumed. This species is formed in first step and consumed in the second step. So, in this reaction, chlorine gas is the reaction intermediate. Chlorine gas is the reaction intermediate. So, the reaction intermediate is the species formed in first step and consumed in the second step, is called as reaction intermediate. We see the order and molecularity of the reactions. From this, the question may be asked in the board exam for 2 marks. Differentiate between order and molecularity. For 2 marks, the question may ask differentiate between order and molecularity. So we have to see the difference between order and molecularity. Here, order and molecularity. First point we have to take is the definition of order and molecularity. number of reactant molecules taking part in the chemical reaction. Means it is the elementary reaction in which number of reactant molecules takes part in reaction. This is the first point of difference. The second point of difference is the order may contain integer, fraction or a zero. It may contain integer, fraction or zero. And in molecularity of the reaction, it contains only integer, not a zero, or it having always integer. It is always integer, not zero. This is the second point of difference. The third point is the order of reaction may changes with the experimental condition. It may changes with experimental condition. In this, it does not change with, that means molecularity does not change with experimental condition. Fourth point of difference is it is based on balanced chemical equation. That means order based on balanced chemical equation. It does not based on, in this side, does not based on balanced chemical equation. And fifth number point is order and molecularity. Fifth number point of difference is that it is meaningless for complex reaction. It is meaningless for complex reaction, and in molecularity of reaction it is meaningful. It is meaningful for complex reaction. Sixth number point, it does not give, means order of reaction does not give the idea of rate of reaction, doesn't give an idea of rate of reaction. And in this, molecularity gives idea of rate of reaction. Seventh number point of difference is it is independent of temperature, pressure and catalyst. Independent, that means order is independent of temperature, pressure and catalyst. And seventh number in this molecularity is dependent on temperature, pressure and catalyst. between difference we can write here. The question may ask in the board exam for 2 marks, differentiate between order and molecularity. If we write only 4 points, then it is sufficient for 2 marks. I have given here 7 points for difference. First we see the definition of order and molecularity. It is the sum of exponent to which concentration in the rate are raised, and in this molecularity is the elementary reaction in which number of reactant molecules taking part in reactions. Second point is it may contain integer, fraction or zero, and it is always contains only a integer, not zero. Third point is it may changes with experimental condition, and molecularity does not change with experimental condition. Fourth point is this order of reaction is based on chemical equation. In fourth point of molecularity does not, or molecularity does not based on chemical equation. The order is meaningless for complex reaction. The complex reaction means it involves number of simpler steps. So it is meaningless in order of reaction, and the complex reaction is meaningful for molecularity of reaction. The order does not give an idea of rate of reactions, and in molecularity it gives the idea of rate of reactions. And the last one for order is independent of temperature, pressure and catalyst, and in molecularity it is dependent, or it may changes with the temperature, pressure or catalyst. Means temperature, pressure and catalyst may change, the molecularity of that reaction is also a change. Thank you.